Greetings. So I made a video the other day talking about the sun. I was pointing out how the sun seems to have changed in color, how it's more intense, how it is whiter now rather than yellow the way it used to be when we were all much younger. Well, there are a number of factors that contribute to that. I talked in the last video about the Earth's center, how the molten core has a solid inner core within that, and now scientists have found that there is even a more dense core within the metal core of the planet itself, which sounds crazy, but it's interesting to note because they also say that that metal core of the planet's interior has stopped spinning, and it did so probably around 2009. And they say that it's supposed to change in direction potentially, but they really don't know what's going to happen with it. But what we do know that has also occurred over the past 13, 14 years is that the magnetic poles, which are different from the actual physical poles of our planet, have also started moving faster toward equatorial regions. The North Pole is moving through Siberia down and probably through Russia further south, while the South Pole is moving up as well toward an equatorial location, probably somewhere in South America. So these two things are happening concurrently, right? The inner core of the Earth has stopped spinning. The magnetic poles are moving toward the equatorial region, and our magnetic sheath around our planet, called the magnetosphere, is thinning. So these three things all taken together point to something happening at a global level that is beyond climate change, that is beyond anthropogenic climate change itself. And it speaks towards some larger pattern, some larger cycle that we're involved in, that we may be coming to a head in, right? So what could these larger cycles be? There are a number of different candidates. There are a lot of people who are talking about micronovas, and micronovas and novas themselves are points at which the sun actually has some sort of explosion that causes it to send out blinding flashes of light and radiation that inundate their solar systems, right? And this happens all over the galaxy. And we have evidence of that as we look out with the Hubble telescope and with the new telescopes that we have that are much more powerful, right? And we look for the source of these types of explosions, and they seem to be occurring successively coming from the innermost part of our galaxy, where there is this gigantic black hole called Sagittarius A, right? Apparently, according to the research of this gentleman named Paul Laviolette, may he rest in peace, there is a wave that is moving from the galactic center outwards, and it has been moving in this direction for the past 60,000 years, and it is reaching our solar system now. So as that is also happening, as our solar system kind of rotates around the galactic center in another cycle, we have reached a point where the oscillation of our galaxy over the galactic plane has reached the actual galactic plane itself, its medium, the part of our galaxy that is actually thin. Thinking about what our galaxy looks like from the side, it looks like a plate, right? The middle of the galaxy is here, then all of the solar systems and the millions and billions of stars we have are kind of like ranged along this plane, right? So we have reached the center of this plane. We have reached what they call the current sheet, the galactic current sheet. And the current sheet is where the energy is densest, where galactic matter, space matter, things like dust, like comets, what become meteorites, and other things of that sort are concentrated, right? And so there's not only more energy coming into our planet right now, there is also more matter coming into our planet in the form of meteorites as well, right? And we can look for that to continue as things continue to heat up. So we have the sun to consider. We have the rotation of the Earth's core to consider. We have this superwave that could be coming from the galactic center to consider. And we have the micronova of the sun to consider as well. All of these things are receiving serious scientific scrutiny right now, and nobody knows, what's going to happen for sure. But we do know that a lot of the things that we are calling climate change are not necessarily because of the plastic that we drop in the ocean. Sobering topic, right? Well, these are sobering times. So it behooves us all to remain updated on the things that are going on. I recommend that you check out spaceweather.com and other locations where you can find out information about the solar cycles, about the daily space weather, because all of that affects us very much here on planet Earth. As more electromagnetic energy enters into our atmosphere, it just passes through the magnetosphere easily now because our magnetosphere is so thin. And before, when it was thicker, that used to keep out cosmic radiation and solar radiation. Now it's very thin, and so more of that energy is getting into our planet. Now, down here where we live in the troposphere, there is this energy measure that's called the Schumann Resonance. And the Schumann Resonance is a measure of all of the electromagnetic potential that currently exists inside of the atmosphere. For many, many years, it was steady, right? But in the past few years, it has gone up very, very high, often off the charts, depending upon what kind of energy we're receiving at that point in time. So the point is that there is so much more energy now that is entering into our atmosphere, and we are electromagnetic creatures. Humans are, you know? So it affects us. It affects our emotions. There are plenty of studies out there that talk about how living next to power lines makes you depressed and makes people think suicidal thoughts and all that other kind of stuff. What do you think all this energy coming in from the sun and from cosmic waves that could be hitting our planet is doing to us? Think about that. And think about all of these different, seemingly unrelated variables that are contributing to the life of our planet. It's very interesting, to say the very least. Thank you so much for sticking with me for almost 7 minutes. I did not plan on this being so long, but here we are. Peace out, y'all.